Hello and welcome to today's Energy Manager Today webinar titled Easy Data, How to Position Your Business for an IoT Future. Thank you to Verdigris for sponsoring today's webinar, and thank you to the attendees joining today's broadcast. My name is Jessica Hunt and I am the Webinar Director for EMT. A few housekeeping items before we get started. Please notice the troubleshooting tips on the right side of the console. If you are still having technical issues after performing the steps listed, please send a message to me using the group chat box located at the bottom of your screen. During today's presentation, if you have questions pertaining to the content of the webinar that you would like our speaker to address, please utilize the Q&A box located in the top right part of your screen, as we have set aside around 10 to 20 minutes for a Q&A session following the presentation. If we do not get a chance to answer your question during the live event, the speakers will follow up with you as soon as possible. A link to the archived webinar will be available within a few short days. At the end of the webinar, we ask that you complete a short survey. Now, before I go ahead and introduce the company a little bit more and the speakers, we have a short video for you to watch. Now, a little bit about today's sponsor. Verdigris is an energy management platform that empowers the world's smartest buildings with data, insights, and automation. Through artificial intelligence and IoT-enabled sensors, Verdigris learns and distinguishes the equipment components of commercial buildings, providing rich data streams about critical equipment. Powerful analytics constantly scan this data to find hidden inefficiencies, produce itemized utility reports, and empower building managers to optimize facilities management. Named one of the top 10 most innovative companies in energy by Fast Company, Verdigris has a domestic and international customer base, which spans 9 countries and 80-plus enterprise customers. Headquartered at the NASA Ames Research Park in Moffett Field, Mountain View, California, Verdigris is a venture-backed company established in 2012 and has raised $22 million to date. We are lucky enough to have the CEO as well as the Director of Growth from Verdigris with us today. Mark Chung is one of the 3 co-founders of Verdigris and its CEO. He was recognized as one of the 40 under 40 in 2017 by Silicon Valley Business Journal. He leads business strategy at Verdigris and sits on the advisory board of a number of startups. His last company was acquired by Broadcom in 2011 for $3.7 billion. Mark studied electrical engineering at Stanford University. Second, we have Matt Falk, Director of Growth, who has 15 years of experience within the industry and an extensive background in mechanical systems and building automation. Starting in the field as an installer has given Matt a unique look at the controls industry, specializing in banking, higher ed, and hospitality verticals, as well as channel management. Matt now works in a unique growth role at Verdigris as Verdigris begins their channel partner product launch. At this time, I'm going to turn the presentation over to Mark and Matt.
Thanks, Jessica. Thanks for the warm introduction. Looking at the audience on the call, it looks like we have a pretty diverse group. So good afternoon, good evening, and good morning, everyone. Matt and I are excited to be here and to share how we see IoT changing energy management for buildings and what energy managers actually need to know to really leverage this technology to their advantage. We aim to show you how IoT can make your lives much easier and allow you to cut energy spend, and as we saw in the case with our client, sometimes up to 50%. So what is IoT? Simply put, the Internet of Things refers to connecting devices or things to the Internet. So what's the big deal? Although machine-to-machine or M2M and connected device concepts have been hyped for a long time, these systems have found pretty limited use until recently, and the IoT industry is really exploding now. The IoT market is projected to attain a compounded annual growth rate of 28.5% by 2020, and B2B IoT sales are expected to exceed $300 billion by 2022, and that's just around the corner. Why is this happening? After all, despite all of this explosive growth, there's still an outdated negative perception of IoT that exists. We've all seen some odd examples of connected devices that don't seem to make any sense. In fact, there are entire websites dedicated to finding products that connect to the Internet for seemingly no good reason. So our first question to the audience, what is the worst example of IoT that you guys have seen? We'll be collecting these and sharing some of these best examples in a few minutes. So back to the question of why now. I will give you guys a couple seconds to look at that. Although many experts will point to a lot of different reasons, I'll argue that part of the reason that why now is really the significantly improved security of connected technologies. And we also have ubiquitous cellular connectivity blanking most urban regions. The rapid growth of the Internet itself has actually driven down the cost of IoT and cloud software to unprecedented levels. And the truth is, IoT is much more than a bunch of simple devices connected to Wi-Fi hotspots. IoT represents a fundamental shift towards a software eating the world paradigm. If you think about it, software has really shaped nearly every business process in the world, and it's also changing how we experience the world as humans. This is why, quote, there's an app for that is now almost a default assumption. But before we can see this Energy Manager downloadable app on the App Store, we need to first make a software capable of talking to the real world. And to do that, we need a universal platform that both understands our analog world and allows us to connect it to software. And that first step is really the digital transformation. Although digital transformation could be another one of these obnoxious Silicon Valley buzzwords, at its core, it's really just the concept that we're quantifying our world digitally. And this process has just begun. We're at the beginning of a massive, multi-decade transformation of our physical world into easily manipulated bits and bytes. And when we're done, we'll be able to program our world with software just as easily as playing a game of Sudoku on your iPhone. And even more exciting or scary, depending on how you look at this, we'll be able to actually beneficially manipulate our world with AIs. The evolution of IoT that we're seeing now is really being driven by businesses. Real-world businesses, use cases, are driving adoption of connected sensing. And I can't think of a more compelling universal business case for IoT than energy management. Energy managers today still rely on traditional, very manual, guess-and-check energy management methods. And IoT can turn all of this into an automated and precise science. And with sensors streaming information in real time and software in the cloud that can automate real-time controls, the ecosystem will continue to gain more knowledgeable and strategic energy managers. Installers and energy service companies and OEMs alike will also develop more sophisticated capabilities, and the market will enjoy better, more rapid business models. And finally, I think we'll see smarter, more efficient, and higher performance buildings. And I'm going to let Matt share a little bit more about that.
Thanks, Mark. So let's take a look at what the status quo is right now for an energy manager or installer before the IoT future. Currently, energy managers spend a lot of time just manually collecting the data in some cases. In some cases, it's using a clipboard and walking around to your different data loggers and marking your points or your data. There's also a lot of time spent maintaining these networks and worrying about said network security. Let's not forget that the hack that happened to Target Corporation a couple years back was actually through a vulnerability found in the HVAC control system. So they're also spending a lot of money on energy costs with only guesses as to where the energy is going and what devices are consuming the most. I guess without a clear picture of even the health of said circuits and pieces of equipment. They also spend too much money adding points on an older BACnet type of system, while changes in technology and maybe in additions on their buildings are costing each of one of these points to go up.
Yeah, I've actually personally experienced this same frustration as these energy managers back in 2010 when I came home from a vacation to an unusually high electricity bill. Normally about $100, this was like $560. And the utility couldn't really provide me any information about what caused all of this extra electricity spend. So like any good Stanford engineer, I had to take matters into my own hands, and I installed small plug-like sensors from Home Depot everywhere throughout my house, and I hacked them to be Wi-Fi enabled so I could try and detect the problem, but nothing seemed off, none of the likely suspects. It wasn't really until I started to utilize some newer algorithms we'd been working on at work to build an electrical map of every device in my entire house, and that's when I eventually detected the problem. And it also turned out to be something that I couldn't have guessed. It was my pool pump that had some broken rotor bars. Now, if you imagine if I had used the traditional control systems that Matt was talking about and installed multiple more submeters, or if I just tried to rely on the utility data the way that so many building energy managers still have to operate today, I would have needed a budget of 5 figures for all of this equipment. I would have also needed to run networking cable throughout my entire house, or paid for a non-existent IT department to spend thousands of dollars to do it for me. Or after all of that, I would have actually also not had the necessary data to identify the source of the problem. And thankfully, just as this problem was happening for me, IoT technology was maturing so that I could solve the problem for myself. And I thought, if I can do this for my house, we started to ask, why can't we just do this for more critical commercial buildings? So that's when we created Verdigris. And our goal is really to help IoT-enabled energy intelligence be brought to every building manager, installer, and sustainability leader. Now, we've been developing this technology at NASA with backing from investors like Verizon and Jabil. But since 2012, we've actually been able to help hundreds of building managers cut their energy spend, and in some cases by as much as 50%.
So why is this IoT energy intelligence so compelling? I guess with traditional non-connected systems, you only get to see like a 15-minute snapshot of your building's energy usage at a time. And that's a best-case scenario in a lot of times. Sometimes you're relying on yesterday's data, or you're relying on intervals longer than 15 minutes. They could be a half an hour. They could be every hour. But even a 15-minute snapshot is an incomplete picture. At Verdigris, our IoT sensors sample at a rate of 8,000 times per second, for example. With this amount of data, you really go from more of a 2D linear view of your building to a 3D view of your building that really holds every circuit and every machine in your building accountable. Only with the fullest, most complete data set possible can we make the smartest decisions for energy efficiency. And this is extremely valuable data, is forever backed up in the cloud, remotely accessible 24/7, with AI working around the clock in the background.
And that's exactly what makes IoT really exciting to me as an algorithms engineer, because it's really about the potential to harness all of that incredibly granular and now super accessible data, and then to visualize and derive insights from it using these AIs. Reliable, accurate IoT sensors are the key to enabling critical insight into a building operations, and here's just a few ways. For example, sensors such as Verdigris can instantly alert building managers to equipment anomalies, and with these alerts, teams can react and prevent failure of critical building equipment. The historical consumption patterns can also be analyzed, and so armed with these analyses, energy managers can make powerful recommendations. This can allow them to boost energy efficiency and safety, all while reducing costs. And then further, the granularity and quality of the Verdigris-like energy data enables some very unique AI features that are far beyond any of the energy management platforms that have existed pre-IoT. So to that original question, what is IoT and how is it helpful? I'd like to poll the audience. What do you guys see as the greatest benefit of IoT to your business? And we'll give you a few seconds to kind of read through what some of those are. And we've kind of listed some here. One of the last options is none of the above. But take a look and see if any of these apply to your business, and take a few seconds to respond. And to do that, I will start to talk a little bit about what we see as some of the key benefits of IoT. So I will skip to the next slide here and talk about the first benefit, which is granular real-time data. So sensors are now much cheaper, much more granular, and much easier to install and operate. Another benefit is that you're going to get to see with better visibility and insights, you'll centralize data into one data lake and gain both the context and the visibility that you're going to need to derive more meaningful insight from your analysis. The third is that you also get a much easier integration, like combining online information like weather, real-time energy prices, et cetera. All of this is creating a much more intuitive and far richer context to derive insight. And IP, which is the de facto standard for all internet integration, is now accessible, and you can really benefit from this from a mature developer ecosystem. And finally, it is IT secure. So there's a new class of truly enterprise-grade IoT devices that we're seeing that bring self-contained networks and that can operate cloud to cloud. And this means that your IT teams can maintain complete control of their information flow, and you don't have to add any unnecessary intrusion points into your business. And I wanted to dispel a few myths also floating around about IoT. And the first is that, it's not secure. And certainly slapping a connection on a legacy system can be a dangerous proposition, especially when it's not designed for that purpose. But IoT doesn't really have to be that way. If you're looking for secure IoT, you should look for vendors that have used cellular networks with VPNs and encryption, and there is a number of growing enterprise-grade IoT sensors on the market. Secondly, it's super expensive to deploy IoT. Well, again, not all sensors require complex IT security processes and hardware networking experts. So look for the vendors that are going to provide their own installation services. They're going to be leveraging cloud software, and they're going to be deploying their own systems. That's how it's easy to identify the really easy-to-use solutions that don't require retooling your current business processes. Another myth is the IoT incompatibility. Now, it's true that certain legacy systems are proprietary, and IoT is generally built to be interoperable. It's actually the principles behind IoT that are open source, and that same principle governs the internet. So if you look for the vendors that have strong API documentation and they contribute back to the open source communities, you'll find the ones that are building really future-forward interoperable systems. And then finally, that IoT is somehow OpEx heavy. So I think a lot of people worry about paying these ongoing fees for data management, connectivity, storage, and analytics. But what's often overlooked is the significant amount of money that the software is actually saving them in the form of a SaaS business model. And I'll let Matt talk a little bit more about that.
Sure. So the combination of these IoT connected devices, of cloud-based software, and advanced analytics leads to significant benefits for both the energy managers and the installers, including, as we have been talking about, full transparency into the energy spend. What's running and how healthy is that thing that is running? Real-time energy management, down to demand response capabilities, and we'll touch on these in a little bit, fixing issues before they are problems, and fully integrated systems that speak to each other and react based on real-time data. And that really is the ultimate goal of controls, and kind of the perception that controls have had for for a while now, but they just really haven't performed up to that level. But the IoT landscape is rapidly evolving. And energy managers, integrators, installers, and sustainability leaders need to understand what's really going on with this technology so that they're ready to lead their facility into an IoT future, which is actually kind of the present as we're showing now. So what specifically do IoT and energy, or do energy professionals like you need to know about, and how will the IoT affect them? For one thing, U.S. buildings consume more energy than every other country except China. The price of this energy is going to rise exponentially in the coming years as renewable energy takes hold. The nature of how this renewable energy is generated is typically like solar and wind farms, and these create peaks and valleys in the supply, causing higher peak demand charges. So we need better data to have reactive energy ecosystems to address the volatility in these peak demand charges. Moreover, half of the buildings in the U.S., half of the U.S. energy consumption in the U.S. Comes from these buildings, and as we saw in the opening video, we think nearly half of that goes to waste. So there's a huge ROI potential here, and the need for IoT-enabled energy efficiency buildings like those many of you already have a role in managing. If you're on the energy services company side, there's an arsenal of new technology that will be needed to help your customers with the changing grids and technologies. Knowing a building's consumption on a 15-minute interval is no longer going to be acceptable. Like Mark's issue with his pool pump customer, and ask why. And a big part of that why is their consumption so high, and you'll need the data, insight to the data, machine health and the circuit health of that building to answer that question in many cases. And again, IoT provides this full building transparency, and the transparency provides a bit of transparency. It will also be a powerful tool for energy service companies. So imagine you're, as an energy service company, you approach a building or a building owner with a series of efficiency upgrades you can make to the building. Say you're going to do a lighting project, you want to do an HVAC project, and then maybe install some VFDs on exhaust fans. With a lot of parts, certain things get line itemed out. Say the VFDs are line itemed out. Now imagine being able to go back to your customer 2 years later, or 2 years down the road, and should you have done your calculations right, you would be able to show them with this advanced data that, hey, we did hit our ROI, and then you could also turn back to that same customer and say, if we would have done these line item projects, we would have been paid off on those too, or we would have hit our ROI on those too. And the reason that we know this is because we have this data, and we can see this circuit from this timestamp, and we can normalize this data based on the weather, and that shows us that would have been paid off. So in essence, this rich data is also a pretty powerful sales tool. Another advantage to IoT is the easy installations with the 4G LTE networks. I guess gone are the days of estimating how many 1,000-foot spools of braided 3-wire cable that you're going to need to get your communications back to some gateway that's really relying on the strength of your customer's IT infrastructure. Like this RS-485 example we're going to take a look at here. I think anybody in the controls or energy services company market has seen these type of drawings before and know what these type of installations entail. As Mark said, control communication is shifting to machine-to-machine or M2M networks, eliminating the need for all these wires, eliminating the need for the IT department. With IoT, huge amounts of data are transferred immediately out of the building on existing safe networks and housed on servers that are protected by military-grade encryption. Because IoT devices ride on these safer, faster 4G LTE networks, you eliminate the need to involve the IT department in the installation in total. So coming from a background in controls and control sales, I don't think there's ever been a project that I've been involved with that immediately hasn't been shot down by the IT department. You know, you could go to them with the best 12-month ROI scenario, great for the building, it makes total sense, and immediately the IT department says, no way, absolutely not happening on my network. It usually takes a little bit. You have to prove your point. You have to go through the whole vetting process with the IT department, which can take a very long time, and eventually your project goes forward. Or you hear, well, okay, fine, but I have to provide the drops, and it's going to cost you $5,000 each drop. And sometimes this is just for like a simple internet output. So this is frustrating for the energy service companies as well as the building owners. I mean, everybody's got the intention to save as much money as possible. The energy managers and the sustainability team in the building are always excited about getting their projects done, and they want to be under budget and implemented as quickly as possible. IoT control installations can be done in half the time. For example, if you look at our Verdigris smart meters, like we're looking at right now in this picture, this is a full 42 circuit monitoring system installed in about an hour and configured in around 15 minutes. Actually, it's 420 circuits if you count our disaggregation engine that is actually going 10 layers deeper on each circuit thanks to our AI engine. These systems are a lower price per point installation than legacy systems. Before, the installation itself could take 2 to 3 hours. Now that's after you go to the hardware store and buy the big piece of plywood to mount next to the panel itself, and then line up your 3-channel logic boards and bolt those to the board. But then after that long and cumbersome installation, there's the IT coordination. That itself can take around 2 to 3 weeks. The connection could take around a week to establish. The turn-on configuration would take a day. 3 months later, you'll finally have your live operation. Versus an IoT system like Verdigris, we essentially install in around 1 to 2 hours. Live operation happens almost immediately, and live buildings data becomes available within a couple of hours. This is beginning to disrupt the power meter and sub-meter markets as well. Although we're sophisticated enough to be, really a full EMS, customers are turning to us to solve simple problems like the main consumption of a building. I know it sounds a little bit overkill, but it is actually cool because we can work as a sub-meter and a power meter, but still with the frequency and the rate that we're pulling data, and again, instead of 15 minutes happening 8,000 times a second, we're able to create a disaggregation engine that'll actually pull out 10 individual circuits within each circuit. And I'll let Mark speak a little more to that.
Yeah, thanks, Matt. Yeah, I think as Matt is alluding, once you have like a really connected system, you're kind of untethered from having to sample data at very low rates. And so, you combine this endless pipe of information that you can collect, and you start to do it at a very, very high frequency as we do with our solution, you now have the ability to leverage on AIs. And so this can build a much more full view of your building. So for example, Verdigris has monitoring on each circuit at a rate of 8,000 times per second. And this is where our AI can actually pull out individual fingerprints of the equipment running on each circuit. So with that level of detail and data, we can actually find problems before they arise. Another example is in motors. When you have, and what you'll see on the left-hand side is the normal visual of a motor going from off to on. And in the traditional way of analyzing it, you're only collecting a little bit of information. But when you start to collect it at a very, very high frequency, as you can see on the right-hand side, you can pick apart the difference between a motor that has no issues and a motor that has rotor bar failures. Another example is when you look at short cycling. So if you're looking at a high rate of usage, at a zoomed out level, you can see here's a pump or compressor basically running 24/7, And it looks normal at a zoomed out level. But when you zoom in, and you zoom in at a very, very high level of detail, you can see that this compressor is actually cycling high and low every 2 minutes, which means you have a compression band problem. You have a short cycling problem, and that equipment is going to fail or prematurely die.
That's pretty amazing that you wouldn't even be able to see that short cycling problem with 15-minute data. But let's take let's future cast for a minute and take a look at this IoT building of the future. So say your building, we're monitoring the energy consumption in the building, and all of a sudden we see that we're starting to get close to our peak demand for the day. So our energy system would send out a signal to, say, the BMS. The BMS could take a look at yesterday's and today's weather data and know that it's going to start cooling down soon. So maybe they'll switch to a less aggressive profile, or maybe they'll cut a couple of degrees out of the chiller loop. At the same time, we send a system to the occupancy system that kind of is aware that it's only 50% occupied. So maybe it's okay to shut down an elevator bank or an escalator bank. Or to the ventilation system, we don't have enough people to demand the full 100% ventilation anymore. We're gonna trim that back as well. So all of this is going to be pretty standard in around 10 years. And all of this is going to be done in real time. And all of this is going to be done via API, and it's not going to be done through tedious point mapping. Now, actually, speaking of point mapping, imagine paying per point for a system like that. That would be incredible. That would be a huge amount of money. And now imagine what you'd also miss with the push-pull latency of legacy controls. Let's face it, most legacy control systems are nothing more than advanced time clocks or a set of digital open-close inputs and outputs. Inefficiently running equipment can cost you 4 times as much in energy usage, and diagnostics is lost without real-time monitoring of data. IoT brings intelligence to these time clocks. So the future is kind of now, where you can install certain IoT systems to make your old legacy systems smarter. With IoT platforms like Verdigris, backnet APIs are available. Old inefficient systems can easily be transformed to generate actionable insights. This is exactly what we've done over at the Grand Hyatt in San Francisco. I'll include a link in the URL below to the case study that we generated from this project. But the project was basically kind of as we explained just earlier with the building of the future, where we took a look at the energy consumption of the building as we neared peak demand. We sent a signal to the BMS, which then shut down non-essential systems. So full energy spend transparency with brains, with the brains to connected buildings, because it reveals consumption and waste. Still, there are many other systems that can work in conjunction with an IoT system like Verdigris to create a fully automated building. An IoT energy ecosystem of fully integrated systems that speak to each other and react based on real-time data. Business models are also changing for control companies, and these changes are a win-win for both the building owners and the energy service companies. On their way out are price per point, or fees nobody would be able to afford with the amount of data that comes out of these IoT systems. Licensing fees are on their way out. Software upgrades, that's an obnoxious one. Expansion packs for whenever you expand onto your system, meaning that you need an expansion pack or you need additional data loggers. And planned obsolescence, that one is absolutely the worst. When you buy a system and then you can't get parts for the system, or the software is not compatible and in less than a 5-year term. Stepping in its place is really the SaaS model. So SaaS is a subscription, or software as a service subscription, and charges far less than what traditional licensing fees cost. As the software and the features get better, the updates are automatically added to your system. So as new technology comes about, as we find better ways to do things, we pass those along to our customers. We don't make you purchase those upgrades. Some integrators are even starting to build these SASVs into multiple IoT systems. And then automatically or kind of built into an all-inclusive maintenance and service contract. Now think of the implications of that, building different IoT or having one particular ESCO monitoring different IoT systems in your building and then also building that into a service contract. This energy service company is going to be able to predict or find problems before they happen in your building, and they're going to be able to schedule their service accordingly. As a building owner, because SaaS is predictive rather than reactive, you get continuous value with much lower rates of problems. As an energy service company, SaaS gives you the power to deliver more consistent service to your clients within a predictable recurring revenue stream. Less time diagnosing and servicing with a connected building. This adds up to a lower cost of ownership for the building owner and additional recurring revenue for the ESCO. Really a win-win.
Yep. That leads me to today, how we've seen at Verdigris that we are using these patented IoT sensors now to collect the most granular data at an extremely high frequency. And we're adding artificial intelligence and predictive algorithms on top of that data to drive unprecedented insights into building energy management. Now, this is leading to immense gains in energy efficiency and cost savings, like you've heard from our example client, Jabil, in the opening video. But what's next, with this kind of granular energy intelligence, Jabil is now actually one of perhaps the only manufacturer of their scale that can automatically report their carbon footprint on a per production step and a per part basis. This is an interesting time. I mean, the IoT revolution is here, and we're basically going from this black and white TV to now a 4K kind of era. In 10 years from now, this will be the standard for new construction in all manner of buildings. Today, energy specialists like you have an opportunity to join us at the cutting edge of this industry while reaping some of the huge cost savings and benefits by making your building smarter. I'd like to thank you all for paying attention to our presentation, and with that, we will present the first response from the poll earlier. What is the greatest benefit IoT could have for your business? And it looks like about 42% of you guys said that better data collection to make better and faster decisions to increase the business performance. 39% said that automating and optimizing business processes with software and AI could save time and money. So those actually seem very tied to kind of the business KPIs. So I think that's really the key, and that's one of the things that we've been trying to stress. So great. About 3% of you guys said none of the above, so that's pretty interesting. I'd love to hear the other ideas of what IoT could do. So we'll open it up for questions. And it looks
Thank
like
you, Mark.
the first question. Yeah. Go ahead.
Sorry about that. I was going to say thank you, Mark and Matt, for that presentation. Now, I had a quick question. Did the poll results surprise you that you just went over? Did you expect that from the audience?
No, it doesn't surprise me. I think it's very obvious that the market is already starting to understand how dynamic feedback systems can really benefit them. So this is an indication that it's really the time. IoT is now.
Okay, great. And
3% number.
And with that, you'll definitely be able to see from our audience who responded. So I know that you'll be able to contact individuals after this presentation to get more of an answer, more information from them to move forward. So right now, I want to thank the audience for sending in all of the questions that you did today. We have quite a few that have come in from the audience. Our first question that I'm going to send to the slide decks for everyone to see is, does your system work with solar?
I can kind of tackle that. So there's nothing that really prevents us from working with solar. I mean, solar is an energy supply, just like your building is an energy load. And in fact, we have several examples, including the NASA building that we're housed in, that we we provide a data layer that allows us to extract how much energy the solar panels are producing in real time, and they can use that data along with the demand data to balance out how they actually charge and discharge other kinds of equipment and storage in the facility. So it's compatible. It's also designed to be additive. So if you have a solar system, you can actually benefit from a better energy management system.
Great, and that definitely makes sense. Our next question is, we are a large school district with 50 plus buildings. Would this kind of system be of benefit?
Oh, definitely.
Yeah. Well, yeah. So the interesting thing for school districts is that you guys have probably the most amount of real estate that you have to manage within a very small maintenance budget. So I would definitely say that the primary parts around IoT that are super valuable is this sense of being able to remotely monitor a lot of things. So, if you're spread across an entire school district and you have all of these buildings operate, pulling all the data into one place can also not only let you see how these schools are performing relative to each other and manage that portfolio, but you also save a lot of resources and time trying to collect information from every single location. So that is, it could be a dramatic benefit. And also, if you also have mandates as a school to reduce your footprint or to fit within some carbon output, it could also be really beneficial so that you can drive those optimizations, and we'll happily follow up.
Think of the benchmarking for that too. So like in the older legacy systems, your only benchmark would be like full consumption of the building. But with like IoT systems, you can actually benchmark the different layers of your building, the HVAC of the building, the lighting of the building. That tells such a different dynamic story.
Yeah, the cafeteria, the
right.
gymnasiums, the classrooms. Where is all the energy really going? So yeah, for sure.
And I find that question fascinating. In my previous life, I was a teacher, so I'm glad that our audience member asked that question. Our next question is, does your system monitor performance of equipment that use natural gas or only electricity?
That's a good question. So our system, the Verdigris system, is right now just focused on electricity. But the whole benefit of IoT is that it's going everywhere. So we do know of companies, and we have partners with companies that have pulse meter readers, which effectively can take your gas or your water information and stream it into a cloud. And once it's in the cloud, it does interoperate with our software, which is highly extensible. So we can ingest a lot of different types of data into that system.
Excellent. Thank you for that. We definitely have time for more questions, so audience members, please continue to send them in. This is another one related to the school system question. We are a school district looking to implement an energy management software. How will your program work with an energy management software?
That's a good question. So it does require us to have a little bit more clarity about what that means, but I'll make some assumptions that the energy management software that you're looking at is really just a business intelligence tool that's collecting information and doing reporting. So we can do that. We can support that in a number of ways. One is we can put our sensors on the facilities that you want to monitor, and we could send that information into that energy management software. That would be one way. Another way is to integrate kind of cloud to cloud. So, for instance, if the energy management software happens to be cloud-based, we can take a lot of the data that they're providing and push it into our system, which allows us to have much richer level of visibility into all of the different aspects of energy management, and it can be mapped together into our business intelligence software. So it really just depends on what you're describing in terms of energy management.
Great. Thank you for that.
Yeah.
Do we have anything to add to that?
No, I was just saying hopefully we could follow up.
Oh, definitely, yes. And you'll be able to follow up with every single person who has asked the specific questions after the event. So our next question, if there are 20 electrical panels in one building, do we need to install 20 hard wires?
20 hard wires. So if there's 20 electrical panels in one building, you would have to install, in our case, for our system, you would have to install 20 systems. You do not have to install hard wiring for any of those. And I'm looking at the company as the City of London, so I happen to know that we have 4G coverage in that area. So in theory, you just install the systems. You don't have to install any additional IT infrastructure, and everything should be able to connect.
Great. Thank you for that very concise answer. I know that he will appreciate the answer that you provided. We definitely still have some time for questions. And again, if we do not get to all of them today, we will make sure that we get to them by within the next few weeks or so. This one, we are a large, older manufacturing facility. How do you think IoT data collection on our energy use can help us? Do you have some specific examples of things manufacturers have done to reduce once they have enhanced monitoring?
Oh, yeah. Tons of examples. But it does happen to depend on the facility and the type. But, manufacturers, I think, are one of the hardest hit in this kind of new energy economy because you effectively have like a primary resource, which is energy, and you're converting that into the output of your facility. And, you have to analyze how that energy is being spent. So a couple of examples like we have with Jabil. One is that by dissecting out all of the energy across their different pieces of equipment, they found some really interesting things, like a lot of their equipment that didn't need to run simultaneously was running simultaneously and creating these massive peaks. And with these massive peaks, they were also getting huge surcharges from the utility company. So all they had to do was really just implement some software locks, spread that operation out, and they didn't have to do that with software. They could have just done that manually, spread that operation out, and they would have seen like a dramatic reduction in their peak and a dramatic reduction in their energy bill, and they did. So there's lots of examples like that. Also examples where the security lighting was being done in an odd way, where every night they would run through a procedure. And maybe this is too much information that they would want me to share, but they would run through a procedure where they just have all the lights on, and as they run through their security sweeps, they would just turn them off one by one. So you'd have all these massive energy usage, and they really didn't have any understanding of how much that was actually costing them to run the entire factory lighting systems for the 6-hour security sweeps. So these were the kinds of really interesting insights that you can derive once you have measurements and metrology in place to really analyze your usage.
Yeah, just the benchmarking too. When you think about a situation like that, when our system would automatically benchmark every circuit, the minute something goes awry or goes out of whack from where it normally stands, you would get some sort of indication or some sort of alert to have you focus on that particular circuit.
Yeah.
In which cases you could find a lot of potential issues. So on the soft saving side too.
Yeah, it's like the downtime.
Correct.
Right?
Mm-hmm.
Yeah.
Wonderful, guys. And obviously you mentioned and you talked about during your presentation your cloud-based system. So how does your cloud-based system send information or signals back down to an on-premise BMS system?
Yeah, so we have typically done this through cloud-to-cloud integration. So usually we have our own BMS internet point that we can take the BMS information, bring it up to the cloud, and then from our software, once we've identified things that we may want to implement as control schemes, we talk cloud to cloud, and then that system gets its new routines from a cloud, basically a software in the cloud.
BACnet over IP.
Yeah, BACnet over IP, essentially. Yep.
Great, thank you for that. Now, can this technology be used in non-electrical applications such as natural gas and fuel oil usage?
Yeah, I think this is similar to the question someone introduced earlier about gas and other types of equipment and information. And the answer to that is sort of. So, I mean, our system really is focused on the electric components, but the algorithms that govern how we detect issues and how AIs can really look at trended data and pick off anomalies, that applies to almost any data stream. So we don't specialize in that, but there are companies, and I am aware of many of them, that can actually also look at your gas data, your gas streams, your water data, and all you need to do is actually have highly granular gas sensors and water sensors, and then you can enable a similar type of solution.
Great, thank you for that. This has to do with some 480D panels, our next question that's coming to you. Do you make sensors for three-phase 480D panels?
Oh, yeah. Yes, we do. So, yeah, the example that we all that we showed on the slides were all our proprietary current transformers. But we just did an installation a couple weekends ago at the largest wine producer in the world's location, and they had, I mean, these were 1,000-amp circuits. So we have interface modules that really allow us to monitor, any size. I was just going to ask if there's a limit anywhere.
There isn't. So yeah, I mean, it's really interesting. We did design our systems to be operable at any of the classic low voltage operation, which is standardly below 600 volts. But we have done installations much higher than that. Yeah, we just showed one style of fishbone type control panel for the illustration, but we have many examples of larger.
Great, wonderful for that. And this question is about planning, and as someone who plans ahead, and I know that you guys do as well from working with you the past month or so, what is the best way to plan ahead for energy use sensors in buildings during construction, knowing it will be phased in later?
Yeah, I would say, well, for us, and I can only speak from our context, I guess, the number one thing would be to make sure you have like really nicely organized electric panels in a convenient centralized location, and one that is actually that has really reasonably good cellular coverage. I mean, I would, if you can do something about it, I would say as you're building your building, make sure you plan the circuits well, make sure your electric rooms are designed well, and plan for the fact that you're going to have to add on additional equipment. That said, I think we are working with certain partners to try and enable better ways to do this built in. So that is also coming. So don't despair if you haven't done that already. We have solutions coming your way, but if you could plan ahead, make sure you have good network coverage in that area, and make sure that you've organized your electric panels well.
I would say, too, anything that is non-proprietary, anything with an open API, really, at this point.
Yeah. Yeah, if you're going to put additional technology in there,
yeah,
make sure it's open. Make sure it's interoperable.
Don't tie yourself to one specific platform, because that platform may not, move as quickly as your business.
Great, thank you guys for that. And that was going to be a follow-up question, too. If you were going to have any solutions for that type of question for our audience members that were on. So you already answered that for us. Back to a question about the sensors, again, seems to be a hot topic for questions. Do these sensors work on three-phase electrical distribution systems?
Yes,
we do. So we do three-phase 4-wire, we do three-phase 5-wire, Y and Delta.
no ground. We just did that.
Yeah,
that
we
one
just
panel
did
just did a crazy no ground 3-phase.
Yeah. So we definitely handle 3-phase. Our system, our particular system is designed to be enterprise commercial grade. So that's why we built our system primarily for 3-phase environments. It does work actually on single phase, which may surprise some people. But that's, we designed it for commercial environments.
Great. And I think with that, we're going to take one last question. It's a little bit more of a complex question, and then we're going to wrap it up for the day. So we have seen a system that disaggregates loads for each circuit, but sometimes it will not be able to learn all about the equipment that is on a circuit. Interestingly enough, it can find one compressor and not a companion compressor. How long does it take your system to recognize every load?
This is a great question. And it's not completely answerable, unfortunately. So, there are, there's obviously multiple ways to address disaggregating and looking for equipment on a circuit. We have two components of this. One is something that's constantly trying to separate the signal and look for new equipment, and that's running all the time. So, depending on as soon as the state of that circuit is changing, that's when we see a new piece of equipment. And that today is actually really accurate for us. So the question would be dependent on when you see things changing on that circuit. So if it's changing every hour, it takes us about an hour. If it's changing every week or month, or it doesn't change at all, maybe like once a year, then it could take us a really long time to discover the other pieces of equipment. So it's kind of, that's the best answer I can give right now, yeah.
Great. Well, I want to definitely thank you guys for a wonderful presentation. Thank you to Mark, thank you to Matt, and the rest of your team at Verdigris for putting all of the work you did in today's presentation. Thank you to our audience members who are able to join us today. We will have a link to the archived version, which will be available within a few short days. I know that you will be hearing from Matt and Mark, and as well, this will be up on the Energy Manager Today website. So this concludes today's webinar, and have a wonderful afternoon.
Great.
Thank you, Jessica.
Thank you.
Thanks, everyone.